Hi, this is about logistic regression analysis. Okay, this is an overview about a lot of different statistics, and here you have two different kinds of this peel shape. The first one is the thing with the stripes, so categorical variable, and the other one is like this one, color gradation, which indicates or implies a continuously measured variable. So let's suppose that you have two types of variables. One is measured in nominal scale and the other one is measured in continuous scale. So if we compare other methods, the regression analysis basically pursues the relationship, discovery of a relationship between or among continuously measured variables. But the logistic regression analysis is a method that is devised for estimating the categorical judgment. Okay, so the binomial logistic regression analysis is for decision making of either or. So men and women, or red wine, white wine, or this kind of question. And the multinomial regression, logistic regression analysis is for the decision making if there are more than two categories. So using binomial regression analysis, we can predict whether this wine will be white or red based on their chemical properties. Like this data set shows that color category has been labeled here, but I suppose that we don't know here, but we only have the chemical properties here. So based on the observational analysis of these chemical properties, we can derive an equation that is used to predict the color of wine. So the logistic regression analysis is used to predict the categorical outcomes with two or more categories. Your predictor, so your independent variables, can be either categorical or continuous or a mix of both in one model. Okay, so quite practical, right? Okay, so why is it working for categorical dependent variable? Because the equation is giving you the probability results following the sigmoid function. Statistical value is used to this z value, and this is the equation how you estimate the probability. Okay, so we take this sigmoid function formula to make a decision making in logistic regression analysis. Okay. So let me demonstrate you firstly how we do this in Spss. All right. So this is the same data set, and here is the color of wine, and the rest are the chemical properties. Right. So color and the others are chemical properties. And here analyze in the regression, binary, logistic. Okay. So as dependent variable, I drop the color, which is a categorical measure, and for this block, I dragged the entire chemical properties here, and I clicked forward method, and the word is frequently used method in social science. If you select enter, then it's like in multiple regression analysis, you include all independent variables. Doesn't matter whether each of them are statistically significantly influencing or not. You take all. But if you have to, then maybe you use this. But here, we don't pursue a very complex equation which contains the entire independent variable. Instead, maybe we have a rather minimum number of independent variables. With that, we can sufficiently predict the color of wine. So forward methods is more adequate because it only focuses the selection of independent variables which contribute statistically significantly. Okay, so wild method here, and then in saving, I clicked probability and group membership. So I want to have more information about the result of the logistic regression analysis. So if you click, usually in SPSS, if you click Save here, then after the analysis, you gain new columns, new variables as the result. Okay, in option, I clicked this goodness of fit test, which is less frequently used than before. So maybe we can skip, right? And for this 90%, I clicked here, and I leave as they are now. All right. Okay. Actually, not much things to do. Not many things to do. Okay. So this is the result. Initially, I had this amount of observation, and the red has been coded as in alphabetical order as 0, and white is coded as 1. So if we don't do anything, then all white wines will be considered as 1. So the accuracy here is like the actual white wine over the entire sum, which corresponds to this %, which means although you don't have any information about the wine, if you randomly say, oh, it should be white, then it's already 75.4% correct, because our data set has almost 3/4 of the portion as white wine. Okay, but we want to have a more accurate estimation. Then we need to conduct this analysis, which I selected as forward stepwise method, and as a result, I have here 10 models. It's like having different multiple regression models if I clicked stepwise method. So same thing. So for the stepwise method here is giving us 10 models. So I can take one out of it. I guess if we take lower one, like with a bigger number, then we will have include more independent variables. Okay, then this is the model summary, and here this pseudo R square is kind of equivalent to the R square value, the determined coefficients in regression analysis, but these scores are usually smaller than regression analysis. So it's kind of fake R squared value. If it's larger, then it's good news. Okay. So to make a simple explanation, I only take step 1 model, which has already ability of 92.5 accuracy, which means among red wine, observed red wine, the predicted value has been like 1,288 were correctly estimated, but 311 wines were estimated or predicted as white wine, which is not true, right? So this is error, and this is also error. The correct answers were either this set or this set. So the numerator part will be this plus this, and denominator will be the sum of all 4, right? Based on that, this is kind of confusion matrix in machine learning, right? So we estimate the proportion of this diagonally positioned numbers, which corresponds to 92.5%. And you know, it's getting increasing, right? So in the end, we ended up with 99.1%. If you really need to achieve highest accuracy, then you can take model 10. If you are sufficient with 95%, then you can take model 4, right? No. Model 2. Model 2 has achieved already 95.6% accuracy. So should we say model 2? Okay. So model 2 here. Model 2 includes this total sulfur dioxide and density as two independent variables. They are necessary to predict the color of the wine. Okay, if you take the most precise number model, then you should look at this model. All independent variables here are statistically significant, as you see here, and you may achieve highest accuracy, but the model will look very complicated, right? So it depends on your decision making. So once you have this data, then you can create an equation, and then you can have the value to predict. And here, as you see here, right? So this value has been added, and this value has been also added. So this is a probability value, and this is the membership value, if you remember, right? So they are corresponding to this one. I don't perform it again. In save option, probability is resulting here, and the group membership is resulting here. Okay, cancel. So the first wine, it actually has been white wine, and the prediction is white too, and it's almost close to 0.99, is almost 1. So with high confidence, it has estimated this as white. By the way, the probability and the group membership is the result of the last model, which has included the largest number of the independent variables. Okay. So this has been the procedure. I have demonstrated you. And let's look into the model adequacy results. So along a lot of the results, we can be interested in these three results. The first one is the chi-squared value of the results. So this is saying that with explanatory variables, there was significantly the improvement. Okay, so when it is significant, then it has been worthy that you have made this model. Okay, and secondly, this model is telling you how much the model has the ability to explain the raw data, and this is called the pseudo R-square values. This is less powerful than R-square value in linear regression, which means that in linear regression model, we are highly relying on this R-square value, but in logistic regression model, we can write down the scores, but it's not like covering powerfully an issue that, oh, this model is covering how much % of the raw data. But it's still worthwhile that you include the result of this in your documentation. Often it is skipped in the meantime. When it is statistically not significant, then this confirms the regression model is adequate. In our Y result was statistically significant, so it's inadequate. It's not because my result is not statistically not significant, so I ignored it. It's a tendency that it often skipped to report about the results. Okay, so this one, chi-square results should be significant, and these two R-square values should be larger. Then you can confirm that this logistic regression model has been confirmed, or the data has been adequate for that analysis. Okay, so as I demonstrate you in SPSS, initially without any information about the wine, we already have achieved this amount of the accuracy prediction, but with the additional explanation, in step 1 it was like that, but in step 2 we had it's almost step 10 level. I think it's a result of enter method. So it's different from our stepwise method. So in this model, all independent variables were included. Okay. So whatever model you have taken, there should be an increase, right, of the explanation. That's the reason why you have conducted this method. So in your report, that by having built that regression equation or regression model, you have a higher ability of explanation by, in this case, 99.3 minus 75.4. So the difference has been achieved through this regression model. Okay, so this is actually the results, the practical results, how you use this, and it seems like the entire independent variables were included. So if you click the enter method, then without filtering not statistically significant independent variables, it includes all independent variables, and with that you still can form equation. But here this beta value is used a slightly different way. So before we go to the making of the equation, firstly, what you need to see here is that significance value of the independent variables, and here quality and citric acid are not statistically influencing on the estimation of the red or white wines. Okay, and this EXPB is telling you that it's exponential score. So if it is smaller than 1, then its contribution is toward 0. Zero has been red wine, right? And toward 1 was white wine. So if more citric acids, then so bigger. If this score is getting bigger, then the value will be bigger, right? Because it's exponential value. So more likely to be white wine. And residual sugar, more likely to be white wine. And total sulfur dioxide, more likely to be white wine. But like alcohol or well, this is not significant, so let's find this one. Okay, fixed acidity is statistically significant, and its exponential value is 0.4, which means it has, if it is increasing, the results will be smaller, right? So we'll be close to 0. 0 was coded as a red wine here. Red was coded as 0, so more likely to be red wine. So that's interpretation. And if you recall this sigmoid function, then like the multiple regression analysis, if you apply the actual observation value multiplied by this beta score, so like actual STT score multiplied by this beta, and then plus actual volatile STT score multiplied by this beta value, and just add all, right? Add all is actually not the probability, but z-score. Okay, the z-score is entering here. So finally, the probability is the result of this equation where the z is from this. Okay. Right. And in logistic analysis, regression analysis, the odds score is also very much relevant. But actually, this odds score is already explained as exponential b in my previous slides. So as I said, if this b value equals to 1, stays the same, and if it's smaller than 1, they're close to 0, and then if it's bigger than 1 and it's close to 1. So if so if residual sugar is more contained, then its impact will be like 1.3 times increasing. Okay, which means the contribution to the probability of residual sugar will be more impactfully contributed. So more likely to be bigger number, which means close to 1. And in our research context, 1 is white wine and 0 is red wine. So more likely to be white wine. Maybe the white wine are more, they are sweeter than red wine. Okay. So in SPSS, it is labeled as exponential value B, but in statistical theory, it's called odds ratio, or OR. Okay, it represents the change in odds of a beginning in the one of a categorical outcome when the value predictor increases by 1 unit. Okay, if this set OR equals to 7, means 7 times higher to fall into 1, not into 0. Okay, right. So if you want to write down a paragraph out of the results, then you can refer or consult this passage, and you can replace the numbers with your own results. Okay. And also, the sensitivity or specificity or accuracy are often mentioned in logistic regression analysis. The sensitivity is estimated through this. So among the red wine, how much percent were accurately estimated? And what specificity is estimated how much of the white wine, so actually the coded 1, value 1, has been correctly estimated here. So in this case, specificity has been more powerfully estimated than sensitivity, because 99.6 is larger than 98.2. So to talk about this kind of issue, you can use this term. And accuracy is like the sum of a true positive, true negative, divided through all. Okay, so the proportion of the cross values. So these are the common terms which are used in logistic regression analysis, and because it's very similar to what the AI algorithm like machine learning or deep learning, when they need to estimate or predict the categorical outcomes, then how much of the answers are correctly predicted. For that purpose, the confusion matrix, which is like this, confusion matrix is used, and that accuracy is used like that matrix is using this accuracy estimation method. Okay, diagonally estimating.